This week on FX Guide TV.
We're at ILM to discuss Monsters vs. Robots in Pacific Rim.
This and more coming up next.
Hello, I'm Angie and welcome to FX Guide TV. This week we visit the water-soaked, alien-attacked and brutal world of Pacific Rim. ILM, with a legacy of incredible work, has produced some of the most jaw-dropping robot fight scenes and amazing visual effects of the summer blockbuster season. Some of this work is just beyond belief, done at a staggering scale of detail, often in the rain or in oceans. It's just incredible. Mike Seymour starts our coverage by talking to John Knoll at ILM in Northern California.
The battle scenes that we tackle are all quite complex in terms of just the recipe that is required to make a shot. So when we're in the ocean, there's the robot and the monster, and it's raining, so there's rain. There's the rain striking the creature, being flung off of the creature whenever there's a fast motion, these cascades of water. There's the characters disturbing the ocean surface, and so all the sloshing and the white water and the foam and the subsurface bubbles and mist, and there's this cocktail of many items that all have to be balanced just right to get a shot done, and it's really the sheer number that makes it as complex as that.
And for the Shadow Dome stuff, that was pretty much pre-vised. I mean, most of the film was pre-vised, wasn't it?
Yes, yes.
And I understand that that really helped a lot because, in fact, you had a really good working relationship with the director in terms of that previs being relevant right through to production.
Yes, and for us, we were learning Guillermo, and also addressing kind of the scale issues and kind of what were the challenges of this film, to not make things look small, to make sure that all his concerns were our concerns as far as never miniaturizing, and eventually when we went to stereo 3D, we had then to take on those concerns as well to make sure that we were always keeping scale. For my work in the Shadow Dome, it's mostly plate-based. So what we did is we had these large-scale, huge sound stages full of green screen and the characters, and then we had to turn it into that they're in this huge. It's like kind of where they would build a space shuttle because these are obviously 225 feet tall. There's a space for each one of the Jaegers, so there's 4 to 6 bays where you'd be working on them, so you can consider how large that space would have to be. And all of that was plate-based, but then CG fabricated.
So you were on set for what, quite a long time?
I was on set for 3-4 months up in Toronto.
So to walk me through, from a technical level, what your primary concerns are on set. Not that there's anything wrong, but I mean, what are the things that you're really keeping an eye on?
One of the main roles we have on set is to collect camera data so that we can accurately reconstruct the camera move in the 3D scene on the computer. Another thing that we want to do when we're on set is make sure that the plates are being shot in a way that's going to make it easiest for us to complete the shots and to get the best looking result. So I work with Guillermo Navarro and Guillermo del Toro to make decisions about where to put green screens, what things should be practical, what things it makes more sense to do in CG. So you never really know, you just have to be there, and when things come up, you have to be able to sort of react to it at the time.
There's some obvious things on set, obviously you want to be there to answer questions, and things are planned, but it seems to me a key part of it is just being active for problem solving. And I was wondering, what do you sort of keep an eye out for on set? I mean, obviously this is a good, well-run production, but what is it you kind of got your radar up for on set?
Very generally, it's projecting yourself forward into post. Looking at the image that's in front of you now, imagining that you're working on the shot, and what will you wish you had done when you were on set. Something that I do see a lot is when you have a character in front of a blue screen or green screen, not enough thought goes into, well, what's going where that blue screen or green screen is, And if it were really present, how would you expose this scene or how would you light it? So you want to head off situations where you're going to get backed into a situation that's untenable later in the composite.
Well, presumably also framing, because I mean, if the characters are this big, you're going to have to leave a lot of space in the frame for stuff to happen in.
Mm-hmm.
Was there anything on set to help with that, or was it just based
yeah,
on the
a little bit. We had a couple of large virtual environments. There's this big maintenance hangar space called the Shatter Dome. And there were the occasional shot where a character was essentially pointing to something that was on set. It's just a big green screen, but we wanted to make sure that we got that about right so that when we're putting the shot together later, he's not pointing in completely the wrong direction or the wrong elevation or something. And we used a rendered panoramas of what the virtual environment looks like, kind of from the center of the stage where we were, and then we had a gyro-enabled panorama viewer that I could just have on my phone or on an iPad, where we could look around and say, all right, well, that's where Crimson is, and that's where Cherno's going to be.
So you had an augmented reality based on
the
gyro in the Apple product.
Yeah.
Cool.
And then in a lot of cases, we just exceeded that, so that we would extend the camera moves and then change if we needed to extend. In other words, we weren't locked to height per se, because we could extend a camera move or extend a going up.
And similarly with the lighting, I mean, the same sort of principle applies. You can obviously fake it out to a certain extent, but very, very high lights like that are very parallel when they hit the ground.
Yeah, we basically were tied to the lighting that was close to the actors. Because of their scale, it was very easy to kind of isolate them and then grow out from there, and then it became a fabricated lighting scenario.
So in a scene where you've obviously got live actors, not a fully synthetic scene, what are the measurements that we're primarily talking about? I'm guessing HDR, but are you LiDARing as well? Or?
We LiDAR just about every set. We do HDRI, we do virtual backgrounds, we take a lot of measurements. We do something we call photo modeling, where we do 360-degree still photos of every prop, every piece of every set.
So when you say 360-degree, you mean around something as opposed to the HDR, which is going the other way?
Exactly, yeah. We do 2 different levels. Normally we'll take a high angle and a low angle, and then we'll go around in a circle and take maybe 8 or so images from different angles. That allows us to do kind of a rough reconstruction of a model that we can use for layout purposes to reconstruct the set and the camera.
Which brings us to these big sequences, which we talk about maybe Hong Kong for a second.
Yeah.
What are your approaches there? Because you can't be filming much on set or even in the studio for getting that kind of stuff.
No, we did a scout. So we did go to Hong Kong, and we sent a team to Hong Kong to shoot both moving footage and a lot of stills, so that we could have a good realistic basis to start from. And we used those photos to reconstruct a lot of the city. We selected a couple of streets that were the basis for where the fight was going to travel along. And then we had to widen the street because, of course, the creatures are so huge, they don't actually fit between the high-rises in downtown Hong Kong. So we have some modified streets. Connaught Street was one of them. And we used it, and then we widened it, and then we had to replace some of the buildings that we didn't have permission to destroy. So we had to take out some of the more well-known landmarks and replace them with generic buildings that we could damage.
And that sequence is taking place at night.
It is. A lot of the movie takes place at night, which is great in some ways. You know, Hong Kong at night is a beautiful city. There's a lot of color, a lot of neon lights.
Well, the reason I bring it up is that at night you get to see into rooms much more than you would during the day.
Yes.
And of course we want parallax in those rooms in a film of this quality.
Yeah.
So you're not modeling the side of a building so much as you are modeling the sort of the entire building.
The entire building, exactly. And we approached it like a bit of a Tinker Toys kit. So we had interior rooms, we had exterior lobby areas, and then we had exterior towers, and we had a little bit of a kind of mix and match. So we could take this tower, the tower from building A, and the lobby from building B, and interiors 1 through 10, and kind of randomize them, put it together, and that would be a building. And then we could mix and match and come up with other buildings. So without having to build too many individual pieces, we could come up with a lot of buildings.
Now, you've obviously at ILM done lots of cities before, but it gets more problematic the more you bust them up, because you can project a room inside a cube and give a sort of an illusion of a 3D room. But if you're going to bust off the front of the building and have furniture fall out, then that all has to be modelled. So the assets for these buildings alone must have been huge.
They're huge, yeah. We approach it completely differently. If the building was not going to be damaged, then we did it with our digital mat group. If the building was going to be damaged, it goes through what we call our DMS pipeline, which is the full-on model paint simulation, destruction pipeline.
So that's a pre-fractured model for the
It
destruction
is.
sims?
We developed a new pipeline on the show. We haven't previously used Houdini in production at ILM, and we took our first foray into Houdini destruction. And so it required a lot of sort of approaching the models in a different way than we did previously. The way you feed something into Houdini is a little bit different than the way you would feed something into our internal ILM destruction pipeline. So we had to build buildings in a slightly different way to make the new pipeline work. In Houdini, you want to approach things as procedurally as possible. So you sort of make definitions of how a pane of glass will break, how a piece of metal will break, how a piece of cement will break. And then you have to sort of name things appropriately so that they get filtered through and dealt with accordingly inside of Houdini. So we had to think about things from the beginning as we were modeling them. How do we want this to break? What material is this made out of? And make sure that it was put together in a hierarchy and named accordingly.
So if you're going down that route, did you use deep compositing? Because you've got a lot of environments to comp into.
We did. We did use deep compositing, and this was the first show where, again, we've done that on this scale, certainly. We've stuck our toe into it, but, it's relatively new. So, yeah, we did. We used a lot of deep compositing, and it was very helpful. So
it does save having to split up a lot of those layers if you are going to put it together. But it's also very data heavy.
It's very data heavy. And again, our disk space requirements on the show were enormous. And that became a bit of a problem towards the end of the show. We did over 1,600 shots on the show. In an ideal world, you're working on maybe 200-300 at a time. You finish them up, you take them offline, you move on to the next batch, Not so necessarily on this show. We ended up having a lot of the shots online simultaneously, either because the edit wasn't quite locked or something would change, or, it just nothing ever works out quite as perfectly as you plan.
Yeah, and unlike like if you've got a fluid sim, a lot of those sim data packets don't need to be moved forward past the point that you've polygonalized them. But the deep comp data hangs in until the last second, doesn't it?
That's correct. Yeah, the fluid simulation data certainly is the largest amount of data. But once you've rendered it, you can back it up and take it offline, and you can keep working on the comp for as long as you want. The deep compositing data has to stick around. So we had a lot of disk space requirements on this show.
And also you mentioned the procedural stuff in terms of Houdini, but there must have been a massive amount of sim work because we talked about things being at night. There's also a lot of water, a lot of rain,
yes,
and a lot of stuff that's being hurled around that's got to be simulated.
Yeah, we have a really good fluid pipeline at ILM that's part of our proprietary software, and we use that for most of the water simulations. When it came to sort of the particulate stuff, what we called the cascade water, which is the water that sort of fell off the characters, the wet characters in the rain itself, ice bits, stuff like that. We tried to move some of that into Houdini. We used Pyro for some of that. We used Plume for some of that. So we have a variety of tools that we can use depending on what we're trying to achieve.
So now what exactly taking so long here?
We pumped the cavity full of CO2. It's like in any other laparoscopic surgery.
And presumably all of the green screen and stuff was composited through your Nuke pipeline?
Yes. Yeah. So we developed some of the initial looks here, and then China or whoever else, wherever else we did the work with the green screen would proliferate that look.
So what about the color science of the looks for these shots? Because you've got the conversion from the raw files from the R3Ds into somewhere, but then you're going to head somewhere else dependent on where the director and the DOP want that to go. What were the artists working with in terms of sort of the look of the files?
We tried to stay raw as much as possible, and in fact with Guillermo, if we did do any kind of a match, it would be to something that he had already matched in Avids or with the color timing, sorry, with the DI, and then we pretty much stayed raw. And then that way, as things evolved, then we could, if we had to push something, we would, but it was, I would say, a minimal to none touch other than what they did in the DI. We also have one for our stereo lookup too, as far as what would happen when it goes to stereo. So we have there's a brightening process that happens as well. And our LUT, yeah, we definitely have a LUT that we used for the film, but it was one size fits all on that.
So this was also a Katana pipeline, wasn't it?
That's correct. We also use Katana. We used Katana previously on Mission Impossible 4. This is sort of a much larger scope than we had done before for Katana. The greatest thing about Katana is that we could really light multiple shots from one scene file, which is not something that we were previously doing.
Right.
So it made it easy, for example, for a sequence supervisor to really light just about every shot in the sequence. In fact, we had some sequences where the sequence supervisor lit the entire sequence out of one scene file.
One of the things that it also sort of manages pretty well is the variations on sort of assets as they get destroyed, textured, scuffed, etc. And I imagine a lot of your assets were moving through that from a chronological film point of view.
Yeah, that was certainly a big complex part of this show. It was a lot like an animated feature in that respect, that having so many different versions that have to be, their continuity has to be tracked over the course of the show.
I think Gypsy had, there were Gypsy version A, B, C, D, and then each of those had a 1, 2, 3, 4. I think we ended up with like 16, 20 different versions of Gypsy, which, as you're saying, after each battle, she would have new scuffs and dents and scratches, and then she'd get burned, and then she'd go in for repairs, and then she'd have an arm replaced, and then she'd go into another battle. So there were a lot of versions that we had to keep track of and swap in and out.
And the creatures go through versions too, because they go through progressive damage. So the one that has the most screen time is this winged creature, Otachi. That from the time we first see it, it's in a fight, and so it gets cuts and bruises and scrapes, and then it gets some more cuts, and it progressively gets more and more damaged. And so I think there's many, many versions of that as well.
And in terms of look, Devin, that final rendering, this is now an Arnold render?
Yes, we've used Arnold as the primary render, with the exception of water. We were doing a lot of pipeline work on this show, and so that was an area that we elected to keep as on the RenderMan side.
Because you were actually updating large parts of the pipeline, really,
yes,
right the way through, weren't you?
Yeah, indeed, yeah. We reached pretty far on this show. We tackled a lot of areas to try and do efficiency experiments with the thought that if I tackle 15 areas, there'll be some kind of problematic showstopper that may prevent 4 or 5 of those from happening. So I wanted to kind of over-target, because you know that you're not going to be able to follow through on all of them. One of them for me was to try and continually remind the folks about how big these creatures are. So
they're nearly 100 meters tall, right?
Yeah, that makes about a 40-to-1 ratio between a human being and the robot. And when we have the actors doing a punch like that, you think about, all right, so how fast is that actor's fist going at that moment of impact? So it was stationary here, and then by here it was going, 20 miles an hour. So you multiply that by factor 40, all right? And now you're going faster than the speed of sound. So you have an object that weighs as much, at least as a couple of city buses, that goes from 0 to faster than the speed of sound in less than a second. Yeah.
Yeah. Well,
maybe we should go a little slower.
We wanted to get to the point in the film where you could be outside a lot and be invested in Gypsy Danger as sort of a character. almost like you are with the actors inside. So there's character stuff. There's this thing of defining what's, how much is it just a vehicle and how much is it a character. There's also there was just figuring out the scale issues and how fast can we move it. We didn't want everything to feel like it was underwater or super slow motion where, typically you go very slow trying to sell that type of scale, but then, all the fights are happening sort of this fast. And so we couldn't have that. So we had to figure out how fast can we go and still have it feel big. And then on top of all that was just how to invest in it, a sense of it being a machine, because we didn't want to use motion capture. We talked about it at the beginning of the project, and motion capture is a great tool for certain things, but for this project, particularly with the Jaegers, we just really wanted to make sure it wasn't completely fluid and organic, that it felt robotic. And so immediately you start thinking of hard stops and starts. Well, you can't do that when you're talking about something that's 25 stories tall. So how do you imbue a sense of it being a machine into the motion without killing the sense of scale and preserving the sense of mass and all that stuff? So those were the challenges, really.
We kind of talked ourselves into a logic that there's a lot of sophisticated automation as part of these robots, and the idea is that it's not directly a Waldo. Right. What the pilot is doing is signaling intent, and then there's a whole sophisticated locomotion system balancing all of that in the AI of the control system. That you indicate your punch or you walk forward, and that the robot logic understands that's what you want to do, and is working within the engineering constraints and the performance limits of the hardware is doing that very thing, but maybe doing it, a second out of sync and a little late, and that kind of thing.
And destruction was actually another challenge because the characters, we're always mindful of how fast the characters are moving, so we're not killing the sense of speed. But then, and we might buy it in an anim render, say, before any of the destruction or water interaction or any of that's been done. But then when those are done at a very realistic with a very realistic look, realistic physics, and so something's crumbling and the little pieces are falling very slowly, or the water's splashing and moving like this, and the characters are moving fast, then suddenly you've got a mismatch. And so that was something else that we had to really struggle with, was like to always remember, okay, when we get this down the road, when Tachi throws Gypsy into this building, all this stuff's going to be crumbling, kind of slowly, and we can't have it, moving too fast.
Is there also this thing, I remember John Lasseter once talking about when he first did Luxo Jr. and he had it, the ball pop, and it just stayed there forever, silent. Right. And he said, no, I need to give the audio guys time to do something. Do you need to animate to give the sim guys time to do something? In other words, just not have them immediately go into the next pose, because we need to let that stuff play out screen time wise, which they wouldn't have when you were doing the blocking?
No, actually, it's a great question, because that was a huge learning experience on this film. And actually, if I had it to do over again, I would do some things a little differently. And where that came into play most often was in these fights where they're waist deep in the water, because you've got a Jaeger, hammers on a kaiju and its head goes into the water, and there's this huge splash of white water around them. And it's an awesome looking sim, but for quite a good chunk of time, you can't see anything that's going on. Meanwhile, the Jaeger is hauling back and has got this great pose for another punch, and you just can't see it. And so we figured out some things as we got further down the line to make the characters read that had to do with lighting, and there was this great idea of using these the helicopters kind of circling around all the time with a shaft of light kind of cutting through the white water and silhouetting the characters, and that helped a lot.
But how detailed is the animator's environment that they're putting them in? For example, there are a lot of water stuff. Is there anything to facilitate the animators, because obviously the fluid sims aren't there, they're just doing that sort of dry, as it were?
We've recently switched over to using Alembic to be able to pass our 3D scenes among any package.
Yeah.
Normally when the animators start, they have a fairly spare environment that they're working in. There might be sort of box approximations for where buildings are and that kind of thing. And usually that's enough. But if we got in a situation where they really needed a very specific match to a piece of high-res geometry, we did have the ability to retroactively feed that back into Maya and let them, really get close match to the high-res geometry.
On this show, we chose, for just a whole variety of reasons. We chose to go with kind of an older paradigm, which is that largely we use, for muscle movement, we used shapes on the animation side, as opposed to something automatic or something built into the rig. After that, then our James Tooley and his department did flesh sims for wobble, and even in some cases for muscle tensing. But most of that sort of thing was done at animation time by the animator dialing in shapes. And we chose to do that because the kaijus were so radically different from one another that it sort of wasn't, it didn't seem economical for us to set up a sort of an overall muscle system for the show, because it wouldn't be portable from one to the next.
If there'd just been one alien throughout the whole film,
it would have been made sense.
Right.
Yeah, exactly. And so we decided to just, okay, fine, we'll just go with shapes. The other thing, it had to do with the way the fights transpired and kind of what we were seeing in the layouts. You know, as the layouts were being developed, I was kind of looking at those and looking at the creatures and thinking, we don't need a huge amount of muscle detail. We need some large masses that do things at certain hero moments. And to me, that just said, let's do it with shapes, and we'll hit it where it most is evident to the audience, rather than building something that's operating all the time whether you need it or not.
And in terms of that stereo process, clearly the film, as you said, moved between being mono and then stereo.
Mm-hmm.
But for the fully CG sequences, and I know they weren't primarily the majority of your work, did you render those stereo?
Yes.
And did that sort of play into any of the shot design and stuff, or was it all pretty much locked by the time that went to?
It did play into the shot design. I mean, John's really sensitive to the stereo process. He's, I would say, an expert on that. And he's
after Avatar and the conversion of Star Wars, yeah.
Right. So he I wouldn't say it drove anything per se, but it definitely was thoughtfully done, as far as we knew kind of what Guillermo's sensitivity was, we knew what the studio's sensitivity was, and then John's aesthetic there. And I think it just complemented the process, and I think it just went easier for us than coming so late in the game. I think it was good that we had kind of all our ducks in a row for that, and we weren't really exploring too much there, I think.
There's certainly challenges with that subject matter. You know, the way the coverage has been designed on the fight sequences, you know, we're in there with the characters, shooting them almost as though they were human scale, sort of human type coverage. You know, it's not like the cameras are in really close to them. You know, we're backed off a figure length, and you know, that kind of thing. So if you played stereo naturally with you know, a human interaxial distance, then your stereo would be pretty flat, and you'd have to rely really on foreground objects to show you the dynamic range. And we've cheated that a little bit. There are times when we're going wider on I/O, but I have gone to a lot of effort to try and make up some of that by, there's usually something motivated in the foreground, whether in the ocean, and we have splashes that can provide some of that additional dynamic range. It's usually raining. Most of our scenes we have rain. And then there are natural stereo moments that happen where you have debris from an impact, or you know, as the characters are fighting each other, especially in the rain or in the ocean, you know, they're all slick and wet, and on the impact we do kind of a rain explosion from that, all the water shaking off. Usually we try and engineer some of that stuff to come towards us.
Because you did render some of the fully CG sequences stereo rather than having to post-convert all of those.
Yes, yes. So the choice to go stereo happened about a third of the way through the post-production of the show. So we had sequences that were already in a pretty advanced state of completion, and we elected to finish those out in 2D and, you know, deliver layers for conversion. And then sequences that were still in an earlier state, we did stereo layout and are finishing all those out in stereo.
So we're now talking about getting to the end of the process in terms of finals, and I'm just wondering, I mean, sort of relatively speaking, just how vicious are these renders? Because this is a lot of physically plausible stuff, a lot of lighting, a lot of ray tracing, a lot of water and sims. I mean, just how bad is it? And ILM's obviously no beginner when it comes to render farms.
Yeah. You know, some of the renders are enormous. Some of the shots, it would take us a couple of weeks to render our beauty passes. And that's on multiple procs, on multiple computers. So, you know, thousands and thousands of render hours and disk space. And certainly the requirements, the physical requirements of the show were by many factors larger than any show we've done in the past.
Really?
Yeah, I mean, this is the largest in terms of disk space footprint, the largest show we've ever done. We're at over 500 terabytes right now.
Thanks so much for being with us, and a big thanks to ILM for all their help and amazing access, without which we couldn't bring you such in-depth coverage. If you want to follow us on Twitter, then head to @FXGuideNews, or on Facebook, just go to facebook.com/FXGuide, where we post not only FX Guide, but also FX PhD news and updates. Well, until next time, see ya. For more industry news, in-depth features, podcasts and forums, check out fxguide.com. And for visual effects training, check out fxphd.com.